Hi everyone, welcome back to my YouTube channel. Okay, so today I'm going to be continuing on with a project that I started in the summertime. So when I say continuing on, what I'm going to be doing is I'm going to be bringing a pile of live streams together into one main part. Well, I was hoping one main part, but I think I'm going to have to stretch it out to two parts, if not three. I'll try and keep it down to two main parts. So back in the summertime, I started this testing and balancing station. I completed it up to about 95%, and then I stopped because I started working on my research. So outside we currently have, well, it's not too bad today, but the weather has been really miserable. There's been nothing but wind and rain, and that has been holding me up with projects throughout the channel. So I'm inside today anyway, but I just want to point out I've also been sick for about 3 weeks, so if my voice crackles, it's because of that. Hopefully it doesn't. I'm going to try my best here. I'm just getting over that old flu, so hopefully we are okay here. So what I'm going to be doing today, as I say, is bringing this video, all these parts together. I'm going to give a wee update to the channel here, and I'm going to just mention one other thing. So I have lots of projects in this room and out in the garage. So these projects I have to sort of juggle between the workload. I can't just focus all my energy or all my time into one project. I have to keep working on everything nice and balanced. So in the background here we have the dodecahedron, this fancy stainless box that I started making. We've got the aperture, we've got the smart gloves, we've got this e-bike battery build, we've got more projects up here and more projects out in the garage. There's lots of them. And when I'm building these, I have to sort of juggle between the different areas. Usually when somebody's building projects, they're focused on one thing and that's their area. I'm juggling everything, and it's just time consuming. I'm trying to get the weather and all that, and you have to sort of work between everything. I also have to work between my research, so that's another problem. Well, it's not a problem, but the research takes up about, I would say, about 95% of my time, and I've really put my head down the last, well, the last year, but over the last 6 months, or maybe the last 3 months, I've really focused on the research, as I say. So in this video, I'm going to be now just giving a wee short intro, moving on to the discussion of these hubs. You might be able to see this bigger one sitting on the floor here, the top of this bench. I have another motor hub underneath the bench here at my feet. I'm going to be bringing that out too. So this is the MXUS 3K Turbo, or MX, and this one is a QS273. So I just want to point out again, this e-bike, well, this bike appeared well over a year ago, and as I say, it's lagging because of all the projects and the much time I'm putting into everything else. But I have made good progress there the last, well, I think it might have been December. I'm going to start it again now very soon, this e-bike pack. But I have made very good progress on the live streams, if you have seen that. I'm going to be making another main video on that very soon, but anyway, let's not get sidetracked here. So this is one e-bike. There is another one. The other one is going to be more of a more complex, more customized. It's going to be, I'm going to manufacture my own frame using stainless steel. So basically, the same way I do all my other projects, I'm going to be fabricating it, and then I'm going to be polishing it into a mirror finish to make it stand out from the rest, of course. So one other thing I want to mention here before I jump on to the actual discussion of these hubs. This e-bike, I'll bring it out here and just show. So this pack, I'll take this tape off. this pack here is the unique shape to match this bike frame. I will be building another pack for the stainless steel frame bike. I will be building another pack for it. So I haven't made my mind up yet what motor I'm putting onto this bike. The initial idea was to place this MXUS, so this 3K turbo, and I was going to basically push a lot of amps through it to give us a high kilowatt. I'm not going to talk about that. I'm going to talk about that when I'm discussing the motors. But I'm now thinking about placing this bigger motor hub, and I'm not sure. But anyway, let's do a discussion of this hub now. Okay, so this is my setup. What I want to do here now is I want to give a discussion on this bigger hub motor, then I'm going to move back to the smaller one. So I think it's important that I just touch on the hub motors because that's what this project is for, the testing station. So I have a lot to discuss here. So I'm going to try and get it all on. Hopefully I don't forget anything. So this is my custom wheel, as I say, and also the custom QS273 hub motor. So I purchased and modified this QS273 hub for the bigger bike. When I say bigger bike, I'm talking about the stainless steel frame that I mentioned. Okay, so this was initially purchased for, well, it was, the parts was initially purchased and it was assembled for the bigger bike to come. But now I'm kind of in two minds. I'm thinking about placing this into the green bike. Why? Because more power, obviously, and also this color combination that I've got going here. So for this QS273, I should just point out first, when I say color combination, obviously the nipples match the bike, and I think it would look really class looking to have this setup in that bike. You know what I mean? With this custom pack. But anyway, I'm going to keep her locked here. For this custom setup, I plan to use a 460 amp fire driver to push this hub motor to 40 kilowatt. So it's a much more higher output bike. Well, it will be a much more higher output bike. For example, it will be capable of short bursts, generally ranging from 35 kilowatt to 40 kilowatt, or a wee bit more, hopefully. Again, this is for the bike. It was initially designed for the stainless steel bike that I plan to, well, manufacture in the future. So what I want to do here now is I want to just touch on the axle here before I go on any further here. And I think it's important that I cover that because the frame that I'm making, this testing and balancing station, it's important that I get the dimensions right, otherwise this is not going to fit in it. So the QS273 requires a 152mm dropout. So that's in regards to a bike. But this frame that I'm building too, I need to make sure that it's wide enough for this hub motor, okay? The axle here is 16mm. The slot that it requires is a 12mm slot. So that's important for this testing station. So I assembled this wheel a while back, but I had to halt its progress as I required this balancing project that I speak of, so that I can balance and test it. So this wheel currently sits maybe about 95% finished, I would say. It just needs tweeted. So it's designed to my spec. All the parts have come from different suppliers. First, I purchased the QS273 hub, which was then modified, rewound internally. Second, I sourced this 21-inch motorcycle rim, this aluminium rim, at the desired width of 2.15 inches, I think it is. I then powder coated it with this nice deep black powder. Then I applied a clear coat over the top of it. So that's why we've got this lovely deep shine here. After that, I then purchased 100 of these nipples seen here. So these are 7075 aluminium grade. So aluminium nipples that are green anodized, just the way I wanted them. So the holes in the rim, I forgot to mention there, the holes in the rim were, I think they were previously 7.5 mil, but I have drilled them out to 7.8 so that these nipples fit. So there's 36 holes in each rim. When I say each rim, I've got another rim to discuss in a minute. I'm not talking about this one, I'm talking about the front rims to match this one. So the spokes are stainless steel. I wanted them stainless steel. I didn't want steel because I didn't want them rusting. Obviously they've went through a change in appearance through a special technique that they used. I think it's like a chemical blackening process or an oxidation process. So that's so that they match the rim. I didn't want that, you know, that stainless steel shine, that silver. I didn't want that against the black and the green here. I don't think it would have looked nice at all. So the spokes are 9 gauge or 3.5 mil diameter to withstand the torque from the upgraded QS273 hub motor. So I got a company to make me these spokes to my desired length. The spoke configuration is like a 1 cross pattern. So if you look here, you can see it crossing just once at this point, my index finger. I considered a 2 cross pattern, but due to the large diameter of the hub and the smaller diameter of the wheel, it being 21 inch, it was not possible. So 1 cross is sufficient as the spokes are short, you know what I mean? So it will withstand the torque, no problem. So it's actually a much more stable configuration than having like a radial spokes and a radial configuration. So what I'm going to do here now is, I'm just going to get rid of this. I'm going to move over to the other rim. But I just want to show this one up a wee bit closer first. So there we have the lovely sort of black finish there, or deep gloss finish I should say. So it looks really well. So all my adjustments are done on the inside here and not on the outside nipples, because obviously it will only destroy them. So using these Allen key heads. So I'm going to move over now to the other one. Get this one wrapped up again. And then we'll get on with the project itself. Okay, so where do I start with this one? So, this is the MXUS 3K Turbo hub motor. It's the first kit, well, it's the only kit that I purchased for this green bike, because remember, this is customized, the one on the ground here, the big one that I just presented. So the hub motor is MXUS and I think the model's XF40. Yeah, there, XF40. 3K Turbo 45H. I'll talk about that in a moment. So it's similar to the QS205 50H. So the MXUS requires 142mm to 145mm dropout. The axle's 14mm and the slot that it requires is a 10mm. So a wee bit smaller than the QS273. So this MTX39 rim can be purchased laced to this MXUS hub motor with 12 gauge 2.6mm spokes. So I think I initially had planned to push this hub motor to, I think it was 14 kilowatt using a Saviton 150 amp controller. So that's with these heat sinks in place. So these are actually purchased, the listing that I purchased had these advertised as QS 205 hub sinks. So I have a wee bit more to talk about here, and I'm not sure if I should go on, but I'm going to go ahead. So the reason I have attached the heat sinks is because I plan to push this motor to its limit. So hopefully it will last if I use it. I'm not sure if I'm going to use it now. But if it doesn't last, well, I'm not going to be sitting at 14 kilowatt all the time. Remember, that's just for short burst and basically let it cool and then go again, all that. So that is peak burst. Short burst generally range maybe 12 kilowatt to 20 kilowatt depending on the controller. I could have used the Saviton 200 amp maybe, but that's pushing it big time here. So I don't want to ramble on too much here, but I think I'm just going to keep her lit because, you know, I've talked about the other one, so I might as well talk about this. So I selected this at the time over the QS 205 because of the extra gear assembly seen here. So it being a 9-speed, so what am I just count? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a 9-speed. Keep in mind the bike has a 11-speed on it at the minute. So 11-speed 3-wheel. So the QS 205 allows a 3-speed 3-wheel as far as I mind, or even a 1-speed. So that's not enough for what I wanted it for. So using a standard 7-speed or a wider gear assembly is usually not possible without modifications. So it's not enough for what I wanted it for initially. So again, just keep in mind that the green bike has an 11-speed cassette in a 150mm dropout. So I'm not losing all my gears with this hub motor if I was to use it. So for instance, the MXUS has, I mentioned this at the start here, the MXUS has 45mm wide stator and magnets, whereas the QS 205 has 50mm magnets and stator. So hence 45H vs 50H. The MXUS gives you more wiggle room basically for gears. So I'm really only losing 2 gears if I was to use this on the green bike. But if I go to use the QS 273, 1 gear max, I think. I could maybe try placing 3 gears on it, but I don't think that's possible. I think you can only place 1 gear on it. So 1 speed. So what I have to talk about now, the hub sink, and then we're going to wrap up here and we're going to move on to the project. So the hub sink, I have only test fitted it recently to this hub. So as I say, it was labelled for a QS 205. I will demonstrate the mounting of these hub sinks in the future, well this hub sink in the future. Currently it has no heatsink paste or thermal grease in position. I didn't apply it even. I've just tested them to see if they fitted the diameter of the MXUS motor hub. And it does, which is great, but as I say, I mightn't be using this hub motor now at all. So it might be for sale soon, we'll see the crack. Anyway, I'm going to move on here now to the actual project itself. I just thought it was important to mention the axle, and I started going off track there, but the axle here is 14mm, 10mm, it requires a 10mm slot. The QS 273 is 16mm and it requires a 12mm slot. Okay, so moving on. Okay, so I've demonstrated the rear hub motors, so I might as well demonstrate the front wheels too. So this is a matching rim a matching wheel that I have purchased, that I have sourced for this bike. So basically this hub is compatible with my forks. So it's 110 by 15 through axle. So obviously it's a 29er, so a 29 ER rim that matches the kit that I've purchased. So when I go to, let's say now that I want to add or place or mount the customized wheel, the QS273 to this green bike, what am I going to do for a front wheel? Well, I'm going to demonstrate that now. I'm already thinking ahead here, planned ahead. So I'll put this away and then I'll demonstrate that. I may as well, because I've shown everything else. Okay, so this is the, well, my idea for the front wheel for the green bike if I was to use the QS273, which is likely now. So I'm just going to reveal this rim. So when I ordered the green nipples, the spokes and the rim for the rear setup, I purchased everything for the front wheel assembly too. So the reason I done that then is just so that everything matches if I was to use this setup, this QS273 in this green bike. Okay, so I hope that makes sense. So the only thing that I need to purchase now is the front hub for the front wheel. I haven't got it, but I do know the dimensions. The dimensions were required in order for me to work out the dimensions of the spokes. So I'll get the spokes first here. Just want to do a wee discussion on the front wheel for the beast setup, I'm going to call it. So here is the stainless steel spokes that are chemically etched, giving us this black colour to match the rim. So this time I didn't need to powder coat the rims. When I say rims, I've got two of these. I actually purchased two of them. So these rims are the famous Japanese XL Tagasago wheels, which are highly regarded as top tier competition grade motorcycle rims, often used for upgrading stock wheels. So I think they're used for scramblers, yes. So this is not a Harley Davidson wheel. The other one is the rear one that I powder coated. So there's that lovely logo in the black gloss. Nice shine of it. So I'm just going to now show the leftover spokes here. So here is the leftover spokes from the QS273 setup. So I think I ordered double, you know. They're identical to those ones, same gauge. One final thing here I want to discuss, just to demonstrate, to show, to present, is these nipples. So remember when I said it, I ordered 100 of them. I think there's about 70 in here still. I only require 36 to bolt the front wheel, but they're there if I need them. So they're 9 gauge nipples. I forgot to mention earlier on, the aluminium, the grade that they're made of is I think I mentioned 7075, but they're aircraft grade. It's aircraft grade aluminium. So the spoke configuration here, let me see. So I just want to point out, I might just, as I've mentioned already, just actually use the QS273 now, this custom kit for the green bike. I might use, well, I'm obviously, it's not going to just fit directly into the bike. I'm going to have to use my fabrication skills to finalise it. I'm going to have to maybe make a swinging arm or modify the swinging arm on the bike. Probably make one. So then I will just do the same again for the mirror polished bike. I will just build another rim. As I say, another wheel. As I say, I've got another rim in the box there. So I just want to do a wee quick demonstration here with these spokes. And then I'm going to move on because I'm sort of getting sidetracked here, away from the project itself. So these nipples this time fit directly into the Tagasago wheel, the XL rim. The green goes really well with the black again. So how did I work out the length of these spokes without having the hub? Well, basically what I did is I drew the circle on a piece of paper and set this rim on the paper. Found out the centre, found out the diameter in which these spokes will connect into, well, if you can imagine circumference, a hole, a circle. The diameter of that circle, I think it's 58mm, and then I worked out the length of my spokes. So there we have it. The spoke configuration here, I think I have it set for a 2-cross pattern. I think a 2-cross pattern is possible with the difference from the hub size to the rim size with using these 9-gauge spokes. Anyway, I'm just going to wrap up here now. Anyway, I'm going to wrap us up again. I'm going to move on with the project. I've talked enough about the wheels and the motor hubs, or the hub motors. I just want to show one final thing here before I move on. So here we have the other rim. They came from Italy. In there. That'll do for the stainless steel bike if I use the QS273 for the green bike. So also one final thing I want to point out here, the tyres for these rims, for this motocross rim that I have purchased are for a Harley Davidson, I think. So 80/90 and 90/90 21-inch Michelin Commander 3. So moving on, we'll get this wrapped up, keep it safe. So starting on with the project again, now that I've demonstrated and presented all these gadgets. Okay, let's get back to the actual project. So this balancing station, this frame that I require, will allow the fitment of both those hub motors that I just demonstrated. Really what I need is a stable stand that these wheel hub motors can slide down into for me to rotate them, to balance them, and also to power them up safely. So I have done a wee drawing here. Well, I done it ages ago, just to give a wee demonstration of what it is I require here. So we have like a triangular frame with 2 plates at the top of it, and we have these little circular tube out the side to stabilize the stand from falling over this way. And this stand is also stabilized because, as you can see, it's extended out here. So if you imagine if I was to draw a center line up the middle of these plates, this stand extends out on both sides so that the momentum, the mechanical motion, when the kick of the motor start up, both motors, this won't tumble. So the 2 plates at the top of this frame are not going to be purely mild steel. What I will be using here is 2 316 grade stainless steel plates for the mounting points. So the wheel motor hubs will sit in between the 2 plates, if that makes sense. So imagine my head being the actual hub motor. So I will be creating 4 slots. 2 for the smaller axles and 2 for the larger axle, which is the QS273. So at the front or the rear we'll have 10mm slots, and at the back we'll have a 12mm slot, and I'll basically just switch between the different slots during the different tests. Hopefully that makes sense. So the 2 slots need to be facing each other, okay? So for the QS205 or the MXUS, we'll have the 10mm slots at one side of the frame, and at the other side of the frame we'll have the 12mm slots for the QS273. So the reason I'm using stainless steel for the mounting points is, well, if you think about this, when the hubs, the axles are being slid down into the frame, into these plates, I don't want the paint in that area to chip or to make the process tricky or sticky, as the motor hubs are quite heavy, especially the MXUS 273. So I don't want it sticking in paint, and I also don't want any paint being chipped off or flaked off and then the plate liable to rust. So that's the reason I'm using stainless steel. So I also want these grooves to be neat and within spec, so no play exists at all, so that they don't need bolted during testing. So gravity will be on my side once I place the axle hubs or axles down into the slots. So my wild imagination has taken over again. I also need to make sure that the frame is wide enough to allow the larger width of the MXUS 273 hub motor, but it can't be too wide for the smaller hubs. So if you can imagine, if the smaller hub was placed into this frame and these plates were too far apart, they would just fall through and slip off the actual grooves. It also needs to be tall enough to allow for the 29 wheel so that it doesn't bottom out on the ground. So if you can imagine, if I build this for the 21-inch motorcycle rim and the motorcycle rim's sort of skimming the ground, when I go to place the other rim in, the 29-inch, the 29 wheel into this frame, it would just bottom out in the ground because the two axles are sitting at the same height from the ground. Makes sense? So I could have had a testing station here and another one here. So basically having a testing station for the MXUS 273 for the bigger hubs and then one for the smaller hubs. But I think that would have only complicated things, as there would have been wires running everywhere, and also it would have required two power supplies. So I'm just going to demonstrate one motor running at a time. So basically in the future, when I'm demonstrating the hub motors running, I'll be lifting one off and placing another one on. Simple as that. So 2 in 1 frame. So I forgot to mention there, this plate is 10mm thick, which is more than enough for the thrust or the torque that these high-powered hub motors will produce, especially the MXUS, the modified MXUS 273, or even this smaller hub motor, which is still quite large compared to the hub motors in the e-bikes in your local bike store. So once this frame is completed, I can then demonstrate the hub motors running for early YouTube videos, especially this beast, the MXUS 273. Then I can test them in the garage, off the bike, just to make sure everything is working. So as I mentioned, there will be 2 plates at the top of this frame. The frame will be mild steel, these 2 plates will be stainless. The 2 plates will be approximately nearly about 4 inches deep by 8 inches long. The first task now that I'm going to start with is working on these plates. So cutting them and cutting the grooves. Okay, so to start this project off, I need to cut 2 stainless plates. So there will be a left hand plate and a right hand plate, and these will be welded directly to the steel frame that I am about to build. But first, I need to cut these plates. Then I need to cut 2 slots on each of the plates. So a 10mm slot required for the smaller motor hub, a 12mm slot required for the heavy MXUS 273 motor hub. So we'll cut these plates now, and then we'll move on to cutting these 4 slots. So here we go. Okay, so the top plate is cut. I'm using it as a guide to cut the bottom plate to the exact same length. So here we go. So the blade's just touching it, no more. So once this is cut, I'm going to move on to cutting the slots. But before we cut the slots, we have to bore 4 holes, 2 at 10mm and 2 at 12mm, so we can run the cuts into the drilled holes. So I should point out, this plate is lined up with the bottom plate at the left hand side here, at this point. It's just a better way, rather than using the tape measure or permanent markers, to get a more accurate cut. So the 2 plates are identical. Not that it's really required for this task or this job. The slots, however, we want them as accurate as possible. So that's the distance between the slots and also the width of the slots, so that the axle doesn't start turning inside the slots. So there we go. Ready for the slots now. Okay, so hopefully you can see what I'm doing here. So we have a heater going flat out in the background, so hopefully you can hear me too. So I'm about to cut these 4 slots now. So 2 10mm slots and 2 12mm slots. So I'm not measuring this out and marking it using a tape measure. What I'm doing here is I'm using these verniers and a straight edge, working off this face, this edge of the stainless plate, and I'm measuring towards the blade of the saw. So I've set the verniers at 46mm, and this first cut then can be a reference to the second cut, if that makes sense. So when I go to cut, well, sorry, this face would be the reference edge. Then this is my first measurement, 46. Then I'll set the verniers to 56mm and move the plate this way, and I will use the straight edge again and measure up to the blade. So the saw is also set so it doesn't go down too deep. So what I'm doing here is I have a stop at the back of the saw set so the blade only comes down, well, 35mm off this bottom face of the saw, the bottom platform here, off the vise. So here we go, we'll start cutting this now. So I'm going to leave this slot exactly 10mm wide. The tighter the better. If it's too tight, I will file a wee bit out of it. So I have to make sure to do the other slot in this plate 12mm wide. So I mentioned before that I'm going to drill holes at the bottom of the slot so we can remove that piece of stainless. But I've decided to do it a different way here. So rather than have a round radius at the bottom of the slot, which would be too small, so this 10mm slot is for a 14mm thread, M14 thread. So if I was to drill the 12mm hole in it, it would be a wee bit too small. So what I'm going to do is I'm just going to create a nice straight edge using the plasma cutter. Well, I will cut it out rough, then we will file the rest into a nice perpendicular sort of shape. So basically the axle goes down and hits a flat base. So that's the saw stopped there now. You can hear it's not cutting no more. So my next step now is moving this plate out to 56mm. So I'll set the verniers. Okay, so I had to change the measurements there. So I didn't allow for the teeth on the blade. So I have the vernier now set at 54.5, so that's 8.5mm difference between the first cut. So I'll just explain what I've done there. So I've got this scrap bit of metal and I've done a wee test on it first. So when I measured between, well, when I done my first cut at 46 and then moved the burner out to 56 to try and get a 10mm cut, the gap was too wide. It was actually nearly, well, 11.5mm. So I've took 1.5mm off my measurement here now. So it's now placed 8.5mm between the first cut. So hopefully that makes sense. So we'll cut this and then we'll do a remeasurement. Hopefully it's okay. Because this is the only little bit of stainless that I've got here. So, well, these two plates. So we'll let the saw go down to hit the stop again. So here's the second plate. So I also need to make this slight adjustment when I cut the 12mm slot too. I hope this is right, or I'll have a lot of filing to do. Oh, my burners. So the first cut was measured at 56 on this edge. Then the second cut was measured at 56. Oh, sorry, 54.5. So that's 8.5mm. So the slower this cut, the more precise. So we're getting there now to the bottom. About to hit the stop there now on the saw. The slot looks 10mm from here now. So that's what it's measured, 9.85. Hopefully it's a wee bit bigger once I get it out here and measure it. Otherwise I would have a lot of filing to do. So that's it at the bottom. So I want this to be, say, around 9.9 or so. There, 9.8, 9.92. So there's a 1/10 of a mil on it, but I will get that with a flat file. Looking good. So we'll do the 12mm slot now. The same process again here. So I'll do these and then we will start cutting these at the bottom here to make or to form the slot. So it's all good. Okay, so this is the 12mm slot. So this time I have set this first cut to 45mm from this edge. So that means that slot, if I was to draw a line down the center of the plate between the two slots, that slot is in the center of the middle line through this edge, as is the 10mm slot. So hopefully that makes sense. I could draw it out on a piece of paper, but I don't need to go into detail here. So the next cut now, to provide a 12mm slot, I need to measure from this edge to the blade 10.5mm. So again, that's to compensate or to make that little adjustment because of the teeth on the bandsaw blade, the way they sit out a wee bit from this face of the blade here that I'm measuring from. So that's it at the stop again. So the two slots will be at the same depth, and that's it. You stop cutting there now. So I'll set this up now for, what is it, 45mm, add 10.5mm will give me the 12mm slot. $55.5, so that's 10.5mm past 45. There we go. So we'll tighten the space and double check it again. So there you work this. Looks not too bad. So we'll track this and then we'll double check it before we cut it. That'll do. So I'll double check this and then we'll cut it if it's okay. Okay, so that's everything cut. I'm just going to deburr some of these edges, then we will start welding the frame together here. Okay, so finally the frame is now welded together, well, tacked together. So before I complete the welding stage, I need to finish off the two stainless plates to hold the motor hubs. So that is these two plates seen at the top of the frame here. So I have these outside here, let me see. So I have these outside, as I say. I'm going to do work on them here now, but I don't have a plasma cutter here, so I have to just work with what I've got here. So the drill, the Dremel, and the files are all ready to rock. So what I'm going to do here now is I'm going to drill a hole on, if you can imagine, if I was to draw a straight line from this cut to this cut, I'm going to place a hole at the side, and then I'm going to file down to the line this way. Same goes for this slot, this one, and this one. So this is a two 10mm slots. Sorry. This is a two 10mm slots here and here. So if you can imagine this welded onto the frame like so, they will be lined up. So this is the 12mm slots for the MXUS 273. So I'll get the camera put on the stand here and we'll get these drilled. Then I will be using the Dremel and the files. I don't want a curve at this point. I want the motor hubs, the axles, to drop down and hit a flat surface rather than a radius, a curve. Because if I was to drill this now at 10mm using a 10mm drill bit, the radius would be too sharp, because even though the slot's 10mm, the radius on the shaft of the motors are bigger. So hopefully you understand what I'm talking about there. So if I go to the motor here, 2 seconds, I'm going on to detail here. So this motor, we've got 10mm, well, I need to make a 10mm slot on those large stainless plates, but this radius is, what do we see if I get a set of verniers here, but I'll find them. Okay, so I'm just going to do a wee demonstration here. I'm going to move on. So if I get the burners and put it on these threads, it's reading 13.9. So that's telling me this is M14, metric 14. This nut. So this radius is from the center point here of the axle to the outside, 7 mil. So if I was to drill this hole out there, 10 mil, at this point, the radius would be far too sharp because it's smaller. So I just wanted to point that out. So I'll get the camera on the stand, get these drilled. So I actually center punched these a long time ago at the bottom here because I was going to drill a hole, a 12 mil hole and a 10 mil hole to match the slots. But the problem is I don't want a radius at the bottom of the slots. I want it straight cut. So that's why I'm going to do it this way. I'm now going to keep the hole to the other side of the cuts. But I got a marker here. So if you can imagine, there's where I want this cut. Here and here. I'll be placing the hole here, here, and here on the inside. So what I'm going to do here first is I'm going to mark these out, center punch them. I'm going to, well, when I get the verniers. So even though this is 10 mil wide, I can't use obviously I can't use a 10 mil drill. I can't use an 8 mil drill because the thickness of the bandsaw blade looks to be about 1.5. So 1.6. So the maximum drill bit size I can use in there is probably a 5 mil on this one. And at this point it is 7 mil. Then I will use a Dremel to remove the excess material that's not required. So I'm going to set this to 3.5, just 3 mil. To give me an idea where the holes are required. So 4 up from this line and 3 up from this one. So the reason this hole's further up is because this gap's wider, so I have to use a bigger drill. There we go. So about a CT90 cutting oil now. I'm going to start off with a 4 mil drill maybe. So just to point out here, when them holes are drilled, I'm going to be using this file when I get this lump of material removed after I use the Dremel. But this file is 10 mil exactly, so at this point where the file tapers, this is where I need to stop filing because it's 9.5 here. So I just need to be careful not to widen the slot. So if you can imagine, if the motor's in the station, the smaller one, the QS205, it will jiggle about. And because I'm not using nuts to fix the motor, the axles or the hubs in the station itself, I need the slots to be tight, not slack. So I'm basically going to be dropping the hub motors into the testing station here. These slots are cut with a bandsaw. So it's 12 mil, quite wide. The stainless is stored in our drill bits if you don't use the cutting oil. So that's one plate now completed here with a 3.5 mil hole. So if this was my steel, it would be much easier, but maybe in me I made things difficult again using stainless. Just making sure it's the centre. There's a noisy tractor coming. So that's 3 done. So I need to be careful here when I go to increase the drill size. If I go too much, it end up breaking the tip off the drill bit here. So I'm sort of going to just move close to the edge here, the two sides, but not too close. So I'm now going to move up to a 5 mil or 6 mil even. So I need to be careful here to break a drill bit. Looks good. Good drill bit, Sam. Presto. Oh, careful. So what I need to do now is remove this rest of this wee bit. I think it's about a 0.5 mil now. 0.54. Using the Dremel. So I've got a wee carbide burr in here. Or tungsten cutter. trying to get this into view here. There we go. So I have to do this now for the other 3 sides, and I then need to tidy up the bottom here, obviously. So I'll do these now, and then we'll move on to the final stage here. So I need to be careful here that I don't hit this nice neat cut, because if I hit that with the Dremel, I'm going to take chunks out of it. And if you can imagine, when the axle of the motor hub's sitting in there, it would end up in slack like that, and I don't want that, because I am not using nuts to tighten the axle or hubs into the slots or into the testing station here. So I'll do these 3 and then I'll move on to the cleaning stage here. There it is, there it is. So this is QS273 and this is MX or whatever you call it. And this is also, it allows fitment of the QS205. So these plates will be welded directly to this frame, spaced out like so. The QS273 will drop on here, and obviously we remove that one to add in the QS205 for testing or balancing. How do we see if it breaks out there now? If it doesn't, I'll just keep our lid. There we go. So 10mm slot, 12mm slot, QS273, QS205. Ooh, started to snag it. Okay, so that's me now ready for the Dremel stage. Okay, so second plate. I could sit down this time maybe on the bench. So starting off with this bigger hole. So the reason I put the cutting oil on it here is just to sort of protect the cutter. Okay, so that's the bigger one done there. So the reason I selected the cone shape is because the hole's much smaller than I drilled on the 10mm slot. So I'm being careful here not to hit the edges off to where I've cut it with a bandsaw. Really watch it don't burn the cutter too. It can happen. But that cutting oil is very effective there. So I'm also pulling the Dremel down towards the bottom of the slot to use this piece here to assist me so it doesn't jump out. Sometimes these Dremels don't like running slow. There's so many of them, they keep breaking down. They heat up. There we go. So that's the last one cut out here. So my next step now is using the Dremel again, right? But I'll be setting the plates like this, and I need to be careful not to hit the edges here, because as you can see they're neatly cut using the bandsaw. Okay, so the idea here now is to use these little carbide cutters to tidy up the bottom of these grooves, but it's going to be tricky. So I'm going to do a wee bit here and then I'm going to end the live stream. So I don't want a radius at the bottom here, so I didn't want to drill a hole. I want a nice straight cut. So I want this part perpendicular to this edge. I have them marked and all there. So I need to make sure that the Dremel doesn't jump up. If it does, it doesn't really matter because the slots need tidied anyway. Let me take this up a bit. I'm going to use the other cutter. So I can use the cold one at the end, the other one being more aggressive. So see what I'm doing there? I'm getting closer. I'm getting closer to the fine line that I have scribed in to the plate using the verniers. So the 12mm slot's going to be much easier than the other side because that there is 6mm wide. So I'm coming up the wall here now a wee bit. Back over the other one. So this one now is close to the fine score on the stainless plate. So stainless, obviously harder to work with in my style, but because I've got these tools, it makes it look very easy. So my next step now would be to file this out square. Make sure to turn it round to do the other side too, working into where I just filed on the other side. So again, keeping the file square. So obviously I can only draw a file there, you can't run it at an angle or cross file. So that slot's not, obviously it's not finished, but as you can see I'm very close to the fine line. So when I take this file to this slot, I placed a wee mark on the file there to not go any further than that, because if I do, the file steps up and goes to a bigger size than the slot, and I don't want the slot to have play in it. So running the file through here to finish this slot off, mainly at the corners, trying not to focus on the wall. If you touch it, it'll not remove excess material. Okay, so what I'm going to do here now is use the Dremel to remove the rest of the stainless to create this nice square cut that I'm looking for. Then I'll move on to the square file itself, using the square file here, seen here, and I'm going to start off with the 12mm slot, 12mm groove. Then I'm going to move on to the 10mm. So a wee carbide burr again, bit of cutting oil helps save the carbide cutter. Take my time and remove this material that's in the way. Try not to hit the edges here. Focusing on the bottom. So this will take time. So keeping the Dremel now nice and square with the plate. Trying not to let it slip. Okay, so I'll move on to the file here now for this one. Okay, so for this final step for these two plates, it's basically running the file through them to remove this material that obviously needs to come out of there to leave us a nice square shape, nice square corner, shall I say. So I have this one brought up to spec nearly. So the two files that I'm using here is the square file and the flat file. So the square file for this 12mm slot, running the file and nice and neat to the corners where the Dremel can't get at. Turning the plate round. And for the 10mm slot, I'm going to be using this flat file because the square file is a wee bit too wide for it. Well, it's borderline. So you can see there, I don't want to remove any of the material off the sidewall, so it's kind of sticky. If I'd leave it too slack. So I'm going to use the flat file here, use this edge to finish this 10mm slot off. Or shall I say 10mm groove. So working into the corners here, keeping this edge nice and flat. Okay, so I'll tweak the rest off camera here, but that plate is nearly complete. What I'm going to do now to finish it is basically just give it a wee sanding at this side. So there's a brush side, brush finish side, and there's a side that's flat and kind of rough. You know what? I'll sand both sides using 320 grit sandpaper. We'll start off with maybe start at 180 grit, work my way to 320 to finish these two plates. So good job. We'll get these sanded now after I do this one. So I'll do this one off camera. What I need to do is bring this one up to this state. I still need to tweak this one a wee bit right enough, but I'll do that now. Good job. Okay, so these two plates are now complete. So my initial idea was to weld these to the inside of the triangular frame like so. So one here and one here. But I have now changed my mind. What I'm going to do is weld these plates directly to the top of this triangular frame like so. Hopefully this doesn't fall off. So I'm just going to explain this in 2 seconds when I mount the other one. Okay, there we go. So the reason I've decided now to weld them to the top of the box section rather on the inside is to keep the same distance in between the plates as is between the box section. So I'm making most of this dimension. So I'm allowing a wee bit of wiggle room here for the hubs. So I don't want those two plates too tight and interfering with the hub motors and the cable and the spacers and stuff like that. So if I go around this side, just because there's more light around here with the light coming in the door, so the distance between the two plates sitting like this is the same as between the two box sections. If I move those plates in to the inside and weld them here, it means we're losing 24mm because each one of these plates is 12mm in thickness. So what I'm going to do here now is I'm going to place a wee taper on this 12mm plate. So this one's about to fall off. I'm going to place a wee taper between here and here because when this is welded, I will flatten the weld. And if I wasn't to taper that, there wouldn't be much holding it. So we're going to basically V it, well not the box section, just the plate, taper it one side between the two marks. And when that's completed, I'm then going to cut these two plates. So these plates then will basically fill this area that's lying open here. But mainly, they're for to add strength at this point. So I'll cut this plate now and basically they will be welded in there to the top of this triangular frame. So at the minute, when them two plates are sitting on the top of the box sections, or sorry, the triangular frame I should say, they are sitting lovely and neat. So I'll put the camera on the stand, we'll get these V'd first, we'll get these two cut, and we'll get them welded up, welded on, tacked on. Then I'm going to do a demonstration with the motor hubs on before I weld the frame and before then I powder coat it. So I have to weld the frame after this, then I have to powder coat it, have to clean the frame, remove any oil, any residue, tidy up any wee bits, sharp bits or any welds that need tidied up. So I'll put the camera on the stand here and we'll get on with this. Looking well. So the first thing I'm going to do here is taper this plate for the welds. So the next step here is cutting these two caps, these two plates out, that will be placed directly here and welded in. Only once the two plates are mounted. So like this, and then this on here. So what I'm doing here is I'm keeping a 180mm dropout between the two plates to allow for the QS273, the bigger hub motor. At the end of this video, I will demonstrate mounting the MXUS, same as the QS205, and also the QS273 onto this testing station. So here we go. Two plates, one for this side, one for this side. Okay, so my next step here now to weld these two plates onto this frame, the two 12mm stainless plates. So I've created this jig. So basically I'm just going to clamp it at this point, and I'm going to bring the V down. That's there for a reason. So I'll show that in a minute. So keeping the clamp as close to where the plate's going to be welded. So that would be here and here. It's actually a wee bit too high. There we go. So these two bits now sticking up will help guide where this plate needs to go. So this line needs to be in the centre of where the two box irons meet. So see here, the reason the V's there is to show this so I can see. But I could have marked the other end, but I'll just do it this way. So placing the plate on at this point, and what I'm going to do is I'm going to clamp it too. Well, if I can get on. Well, I can't get on. I can use a bigger clamp. The bigger clamp, I'll put a bit of weight on it, but there's not much I can do about that. So I'll turn this round so you can see what I'm doing here. So if I line this mark up now, I'm going to lower this a wee bit. This other plate down a bit first. So see what I'm doing here. So if I get the plate now that needs to be welded on, all that I do is line the mark up where the two box sections meet, like so, and put the clamp on, the bigger clamp. So that's alright for me to weld it there at that point. So I'll get the MIG set up here. I'm just going to double check this. It looks okay. I'll just turn it right. Aye. Looks alright, you know. Right, so we now have the 12mm plate lined up to the point where the two box sections meet. So that means I can tack it, and it means it's lined up. I just need to make sure it's tight this way and weld it. So now I can remove the red clamp, and I can also remove the two wee ones. So my next point now, next part is make sure this plate is square, so it's not. So if I tap it this way a bit, so keeping it square or parallel to the box section. Need to be careful here I don't knock that down. So what I'm going to do here is put a couple of tacks on this first, just to keep it from breaking, because I welded this a long time ago, 6 months ago. That one's alright, I think. Okay. So, my next step here now is welding on the plate that will support this side. So, the ones that I just cut. Sorry, I have to reposition this camera here, the other one. Okay, so roughly lining up this stainless plate to where it needs to go here. So this is not only a plate to support this one, it's just to tidy up the frame itself. So this plate is still not square, so what I'm going to do is I'm just going to tack this plate for the meantime. Wee small tack. So what I want to do now is make sure that plate's square perpendicular to this face. So I'll just run the square on it. It's not important, but it's near enough. So what I'm going to do is I'm going to tack it and I'm going to tap it down gently. It's alright, you know, the weld will pull it down as the weld cools at a contract. So at the minute, this 12mm plate's not welded to this cap. So this cap is 3mm to match the box section. So I'm going to go around the other side now. Get everything, have to do it all again because this foam is in the way of the 4K camera for the main video. So when I weld on this second plate now, I need to make sure that this slot is in line with the other one. If it's not, the motor hub will sit like this rather than nice and straight. So this still needs to be squared up yet, so that's why I haven't welded it to the cap that I just put on. The cap that I just cut 2 seconds ago. So I need to make sure this plate's running parallel to this box section. It's not at the minute, but I don't want to tap it like this. I'd rather put it on the bench like this. Let me see. Because the frame's not welded yet. Yeah. What do I see now? So I'll just show what I'm doing there. See the way there's a bit of an air gap there at the top? It's not much. If I get a pair of vice grips and pull it over, or a shifter, sorry. So pull it over to its square without breaking the frame down at this point. That could something fell there, that could happen. There we go. That would be really awkward on the live stream if it fell apart on us. So a wee tooty bit yet. I'm just going to tap it. So that's staying there now, it's perfect. So I'm going to tack this before I move on to the other plate. Just going to look down on it, make sure it's okay first. It is. Right. So I'm just going to hold this square. That's it everyone, so I'm just going to tack it here. I'm just going to check it because it will pull over a wee bit with the heat. When it's cooling down, when I weld the other side, it'll pull back over again. It's only a wee tooty bit. That's more or less perfect. So when I weld this V that I just created, this will pull over and then I can weld the other side again. Like I'm talking, it's only a wee fraction. So what I'm going to do here now is I'm going to use this jig that I made up just at the start of this video, and I'm going to push it down here. So the reason there's a V in there is to allow me to see where to line this mark to centralize it. So if I clamp this, there's perfect. There's perfect. Keep the clamps as high as possible to the thin plate, because the thin plate will wiggle if I have it down too low. So them two triangle parts are there now just for me to line this part up. So I'm going to turn this around to demonstrate that. I could have just used this, but because it's lower, we can't we're just using our eye. So if I turn this around now to demonstrate that. So this plate that's on there now, I can see where the two box sections meet. Okay, so if I get this plate now and see this permanent mark that's on there, if I just line that up to where the wee join is, the wee gap in the box section, and I clamp this using a bigger clamp now this time, because the wee clamp's not deep enough, then I can place two tacks on this. But before I do that, I'm just going to confirm. I'm going to confirm that these two slots are lined up by placing a straight edge in here. So I'm just going to remove it square. I'm just going to use my eye for this, because there's no other way you could do it really. Looking down on it, it should be near enough. But to save any handlings, I'm just going to make sure this is right before we go any further. Okay, let's get this welded, tacked like the side. So again, I'm just going to check this mark. Looks alright, you know. Looks alright. So the two 10mm slots is to the right hand side, and the two 12mm slots is to the left hand side. So the only thing I can do here is tack this in the meantime. Keep a wee pressure on it because of the weight of the clamp. Just going to move the clamp now actually. So I'm just going to cramp it with my hands instead. These small tacks. So I can now remove these, the jig, as I call it. Done its job. So if I get this straight edge now and run it here, these two faces are flush. Okay, so my next step here now is making sure that this plate is running parallel or true to this face. So I'm going to use a straight edge, placing it on here like so, and it's actually perfect this time because I took the weight off the clamp. Well, it's near enough. So what I'm going to do here now is I'm going to fill this hole using the wee cap that I cut at the start of the live stream. So I'm going to keep the brush finish up only because the other side is up. So this is a piece of stainless. So this part will be powder coated. So I'm just centralizing the plate now to this edge and this edge, keeping it tight to here, to the main plate. Now I'm just going to make sure it's square because I don't want it sitting off either. We're nearly ready for testing here, by the way. So I'm just going to square it, make sure it's perpendicular to here. It's going to town right enough, isn't it? Alright, you're never going to see it. It's perfect anyway. Oh, nearly fell on the inside. Right. Let me get this right once. So wee small tacks. Checking it if it's square now. So it needs a wee tap down on the inside. So I'm just going to use this. So if I put a tack here now, as the weld cools down, it will pull on tight. So I'm not welding this plate. I'm only welding the cap at the minute to the box section. So that's perfect. No splatter. What we like. Okay, so my next step now is double checking that this 12mm plate is perpendicular. Well, I'm not going to go with this plate. I'm going to go with the face here. Starting to look well. It's starting to look like the drawing I done. Okay. So what one am I at here? This one's welded, it's tacked. So if I place this square now on the box section seen here and check the gap up this face. So you can see there's a wee air gap there at the top. It's only about a half of a mil. So what I can do here is basically just give it a wee pull. But before I do that, I'm just going to make sure this is welded because, as I say, this is welded. The frame was welded a long time ago. Tacked. It looks alright, you know. So we pull over rather than tapping it for things to go wrong. So I'm actually too far there now. But as I weld the other side, it will pull over a wee bit. Put a tack on it. It's perfect now. So we'll tack this side too. So I'm going to tack a 12mm plate now to this cap. Okay. So just a wee small tack here. That's perfect there now. Now I just run my another one. Right, I'm going to put a wee tack on it. Right, that's it, tacked. Right, so I'm just going to move some of these tools out of the way to do this demonstration. It's a bit sticky. And you know something? Oh, that didn't work out too well. It's a bit sticky now. So, what I'm going to do here is I'm going to give him a wee file because I don't want to score the crap on it with the stainless, the axles. I think the 10mm might be tighter than the other side. So I'm going to get up on the bench here to lift this off. I don't want to be damaging these things. See, that's too tight. Mightn't even come off now, by the way. Did you try the other one? Hopefully it does. Ah, dear. Oh dear, Jeffrey. There, it's coming. Okay, so as you can see there, I need to make a wee adjustment for that hub. So it's really accurate, but as you can see, there's no play there. So what I need to do here is give this, one of these edges, a wee file. So I'm going to get the bigger one here. This is my big one that I have built up myself. So I need to be well careful. But see if this one goes on with the weight and it's too tight, well, we will have problems getting it off again. So I'm being really careful here not to wreck this rim. So the rim that I have used here is a Harley Davidson. I'm not getting on the bench for this demonstration because this is really heavy as it is. So I have to be really careful here. Okay, I'm going to go for it. Ah! It's heavy. It's really heavy. Oh dear. Oh dear, is it going down? I can't see the other side. That is perfect. That is unreal. At least that one worked. So, I'm going to take this welding helmet off here. So, finally I have the motor hub testing station all tacked together. So, what I'm going to do here now is place the camera on the stand up nice and high and demonstrate the welding process here. So if you want to see this in more detail, do get a look at livestream part 3 on this project. So when the welding stage is complete, I'm going to move on to the sandblasting stage and then swiftly on to the powder coating stage. So I don't know what colour I'm going to do the stand yet, or the testing station. I might do it a yellow or a bright orange, like that computer orange there. I'm not sure yet, but I will be starting off with a zinc primer. So let's get the camera on the stand and get started here. So this is a welding helmet that I use for the big welding. So I don't want to destroy it before the splatter there, so I'll get it now. So the top of this cap, we sand it nice and neat with a flat disc, removing the weld. This point here. So this heavy plate now, turn the weld up a wee bit here. So when these two parts are welded, right, I only need to weld the tubes then. Lovely bubbly. Lovely jubbly. Will be sandblasted at the end of for now. I'm not be doing it today. Next week. Then I'll powder coat it on the oven. So I think I've only one more end of one of the tubes to do here, so switch to run that like a river. So I'm going to position this here again. It doesn't take long at all. So wee bits of splatter. Wee bits of splatter here and there, but not bad. Might get it sandblasted today. We'll see. So Now that it's welded, what I'm going to do is I'm going to clean up any of the areas that needs cleaned, and then I'm going to take it outside and blast it. Not the stainless plates, just the actual my steel itself. And I also have to tap 4 holes at the bottom here where the clamp is. So 6mm holes, and those holes will be for rubber feet that I can adjust for the station. So these ones, I might put a rubber one on them, and like adjustable thread, 6mm threads here. Not entirely sure. It's just a thought that came to me at tea time there about adding me feet. Not really required. Say if you set this on grass or on something, it's not going to scratch the powder coat finish. So that's it. Moving on to the next stage here. So that's it, everyone. Don't forget to look at the live streams on my channel that I have referenced throughout that involve the entire processes, the different tasks completed here. Part 2 will follow very soon of this project before the end of February. I'm hoping for the end of February. If you have enjoyed this video, please give it a thumbs up. Also, if you want to see other unique and interesting projects like this one or the ones on my channel, please subscribe and hit the post notifications bell to see all the latest from my channel. On the other hand, if this extremely high level standard of work annoyed you, give it the thumbs down. Also, if this quality of work hurt your feelings, or if you're a jealous hater for no other reason other than having your own problems, give it the thumbs down and good riddance. Remember, people, individuals who have showed hatred or jealousy often challenge my abilities, my work, my talents, my originality, as my achievements highlight their own insecurities. To manage them, I avoid over-exploiting the situation. I set firm boundaries and focus on providing consistent, high-quality work or results, consistent with the projects or aligned with the projects presented on my channel. I defeat them just by being me, and that's what they hate. I do it while remaining modest and allowing my achievements to convey my worth. So, goodbye to the haters, but also goodbye to my friends and the genuine. See you in the next video, part 2. Bye.